In this video lecture, we're going to go over lots and lots of examples of various standard cookbook operations upon 1D arrays. Okay, let's get started. Just as a short recap of the prior lecture materials, arrays are useful for us when we need to perform the same set of operations on every element of some collection of like-type data, whether of one of the 8 core data types or some more complex objects. Unfortunately, Java doesn't allow us to operate upon an entire array all at once. So, we need to use for loops together with arrays to cycle through all the elements of an array in succession. Fortunately for us, there's the same standard code pattern involved in doing this. In all the examples which follow, keep your eyes open for this standard for looping pattern. In a for loop, we loop from 0 up to, but not including, the last index of the array, which is an automatically available parameter of any array. Then inside these curly braces, we do whatever it is we need to do to any or all of the array elements. In all the material that follows, we'll demonstrate many standard cookbook patterns for various common array applications. Study and understand these examples well, because you'll see these over and over again in programming, and there's no point in reinventing the wheel. These are just standard patterns you need to know and use. So as we get started, know that all of these examples can be found in the example file array1dexamples.java and its associated demo videos. I strongly encourage you to download this example, open it up in JGrasp, and follow along as you view its demo videos. Okay, on with the examples. Here's a list of standard, typical cookbook array operations. By cookbook, what we mean is they're simply a very standard way of doing these things, so don't waste too much time thinking about them, just know how to do them. We'll go through all these examples in the order shown. In order they are printing all the values of an array, initializing the values of an array, either to some constant value or some algorithmic expression, reading data into an array, either by prompting the user at the command line or reading data in from a file, summing arrays, or just totaling up all its values, averaging the values of an array, which just combines summing and counting, finding the min and max values of an array and at what index they occur, copying one array's content element by element to another array, resizing an array, which typically means increasing the array's size while preserving its existing content, determining the equality of two arrays, do they have the same size and contents, and finally, using arrays as counters, or tallying up various possible outcomes. Okay, let's start looking at all these examples. Here are 2 examples of printing an array, both on separate lines and on the same line. In both cases, as always, in our for loop we're looping over the entire array using the loop index I, then printing out the ith array element each time. The only difference is that on the left we're using println to print each array element on its own line, but on the right we're using print to keep the elements on the same line. But then we need to insert a blank space following each element. Then when we're finished displaying this output, we should also print this blank line to kick the output down to the next line, as we see here. Here are 2 examples of initializing an array. On the left, we're looping through the entire array and setting each element to the same constant value of 100. Just as confirmation, after we do that, we're also printing the array index and the element value in 2 tab-separated columns with the output shown here. On the right, we're doing the same thing, except that we're setting each array element to some algorithmic value. Here, the first value is 10, and we're incrementing the value by 0.2 each time. Again, we're echoing out each array index and its element value, giving us this output. Notice that in each case, the controlling for loop statement is identical, and in each case we operate upon one single generic array value, the ith element, in these 4 places. This is the general pattern we said we'd see over and over and over again. Here's an example of reading data into an array from the command line. Once again, we're looping over the entire length of our array, and for each array element, we use our utils class to prompt for some double value using the scanner input mode. This entire right-hand side resolves to one double value, which we assign to that array element. Once again, as we go along, we echo out each array index and its contained value, giving us the output we see down here. Now notice that here we've got the prompts and the data echoes interspersed like this, but if we didn't like that, we could easily break this into 2 separate for loops, one for initialization and one for display. Once again, the controlling for loop statement is dead identical to the previous examples. All we change is what we're doing to each array element. Here's an example of summing up all the data in an array. Here, we're again looping over our entire array and adding each array element to the running sum, which we've initialized to 0.0 outside and prior to this for loop. A couple things to notice here. First, the sum needs to be of the same data type as the array it's totaling up. And second, notice that by declaring this variable in the midst of this code example, I'm breaking the usual direction I've given you of declaring all your variables at the head of your file. Here, I'm only doing this for the purposes of illustration, to keep this declaration in proximity to where it's being used. So in this case, the array name is simply the one we initialized in the previous example to user input double values. So after the summing loop is over, we print the sum out in two ways. This left output here is simply the raw value of this double variable sum. However, due to calculation inexactness involving floating point numbers, we have all this residual numeric representation. Because we might want to truncate its appearance to only one decimal place, here we apply a format specifier to the sum and get this much nicer looking rounded result. The value stored in sum hasn't changed, only its outward appearance has. Once again, no changes to the controlling for loop statement of this loop. It's always the same general form. Here's an example of averaging all the data in an array. This example is practically identical to the previous example of summing an array with this one added step. After the summing in a for loop is completed, we simply divide the total by the number of array elements, which of course we have automatically available to us via the length parameter of the array. Once again, we're printing the result in two different ways. This first number is the raw value of this average result, and it encompasses all the internal numerical approximation. The second number is the visually more pleasing rounded result, which comes from this format specifier applied to the same numerical result. Again, the value hasn't changed, only its outward appearance has. And yet again, the exact same for looping statement for this different array application. In this example, we're looking for the min and max values of our array. Here we're using the same double array with the same values as we initialized a few examples back. We start off by declaring these two int values and assuming that the min and max values are both found at the 0 element for starters. Then, in this one single for loop, we loop over the rest of the array, starting at index I equals 1 this time, in a small departure from the prior examples. In these two if statements, we check if each array element is less than or greater than the current min or max value found at these two indices. And note that these two selection statements are completely decoupled from each other. The second one is an if, not an else if or an else. If either statement is true, notice that we only update the index of the min or max value to the current loop index. We aren't saving the actual min or max value, only where it's located in the array. Once our loop through the array is completed, we know the indices of both the min and max values, and we can print these two statements involving the min and max indices and the min and max values that are located at those elements of the array. This is a little easier visualized by executing it, so I encourage you to take a look at the walkthrough demo of this application. This is a long set of lecture materials, and there are more application examples to look over, so we'll end this lecture video here and pick back up with the next set of examples in the next lecture video.